Hi, today we are going to explain why Alpha ESS is using lithium iron phosphate technology. Most stationary batteries use some kind of lithium technology, but bear in mind that different types of lithium batteries are used. So-called lithium NMC batteries, for example, are widely used in electrical vehicles. Alpha ESS only uses lithium iron phosphate for its battery storage systems. Hi Vincent.
Hi Jeff.
Why don't we all use the same battery chemistry?
Well, let me explain the difference with an example. Lithium NMC cells have a higher energy density than lithium iron phosphate cells. It means that NMC cells can pack more energy into a smaller space. This is of course very useful for electric vehicles, but irrelevant for static systems like home batteries. Some manufacturers of home batteries also produce electric vehicles. They use the same battery technology that's used in cars for their home batteries.
I see. But in a house you normally have plenty of space to install a battery.
Yes, indeed. But for home batteries, safety is key. Lithium iron phosphate cells are much safer than lithium NMC cells. This is shown by a perforation test. So, first let's have a look at the lithium NMC cells, which we will puncture with a needle. Immediately, a violent chemical reaction kicks in with extremely high temperatures, reaching till 700 degrees. So, this will start a chain reaction to neighboring cells. These fires are very hard to extinguish. This is not something you want in your garage. Now let's look at the same test with a lithium iron phosphate cell. You will see a chemical reaction taking place. The temperature in the cell is rising, but not as quickly and as high than with the lithium NMC cells. The maximum temperature will be around 130 degrees. This is not critical.
I see, but I'm not going to puncture my battery at home.
No, of course. But people typically install their home batteries in their garage. So just imagine what happens if you run your car into your home battery. Or the smallest fire could lead to a chain reaction. With lithium iron phosphate batteries, you can simply sleep on both ears.
Okay. I've heard, Vincent, that LFP batteries, lithium iron phosphate batteries, have a very long life. Can you explain me why this is so important?
Well, with a home battery, you want to charge and discharge your cells at least 250 times a year. In the near future, home batteries will also be used for grid stabilization, which will require additional cycles per year. When you fully charge a battery from zero and discharge it back to full empty, you've made one cycle. With accelerated life tests, the degradation of batteries over time can be tested. It is clear that lithium iron phosphate batteries will lose very little of their initial capacity over thousands of cycles. Alpha ESS batteries typically loses less than 20% of the initial capacity over 10,000 cycles. Opposed to NCA or NMC batteries, which lose 50% of their capacity after around 4,000 cycles. For electrical vehicles, this is okay, because for a Tesla Model 3, 1,000 cycles adds up to 500,000 kilometers. But it's not good enough for a home battery.
Vincent, people buy a home battery to take part in the energy transition. But is a home battery also environmentally friendly?
LFP is indeed environmentally friendly. No use of heavy metals at all, like lead. The lithium iron phosphate cells used by Alpha ESS are also cobalt-free, so no raw materials from conflict areas in the world. This is not the case for many of the other technologies like NMC or NCE.
So we've learned, in fact, that Alpha ESS uses the best performing, the safest and environmentally friendliest material for their home batteries.
Yes, indeed.
Thank you, Vincent.
You're welcome.